everybody. Welcome back. Or if this is your first time here, I hope you find this helpful. Welcome. Today in this lesson, we are going to work on adding and subtracting mixed numbers. You should already know how to add and subtract fractions with both like and unlike denominators. If not, I do have a video for that on my YouTube channel, Math with Luger. I would encourage you to check that out first. We'll also continue to use some positive and negative numbers, so make sure you are familiar with integers as well. Okay, moving on then. So the first thing I want to make sure you know how to do before we dive into these problems is how to convert mixed numbers to improper fractions. In my class, we call this the C method because we make a big C. So like if you have 5 3/8, we're going to start at the bottom and we're going to make a C. You take the bottom number times the whole number, and then you add the top. That's what makes that C shape. So I'm going to do, let me get my pen going here. I'm going to do 8 times 5 is 40. 40 plus 3 is 43. I'm going to keep the bottom on the bottom, so 8 stays on the bottom. If you want to make sure you're right, 8 goes into 43 5 whole times with 3 left over. That's where the 5 3/8 comes from. If it's negative, just go ahead and write down the negative first, then ignore that. So just think about when you make your C, don't include the negative in that C. So I just copied over the negative. 2 times 7 is 14. 14 plus 1 is 15. And I'm going to keep the bottom on the bottom. Again, if you want to double check, 2 goes into 15 7 times with 1 left over. So 7.5 would be correct. So the reason why I did that, I do feel like with a lot of these problems, it's going to help you out a lot if you first change them to improper fractions. Instead of leaving them as mixed numbers, convert them to improper. There's 2 cases where you kind of run into trouble. For example, the first one that I have here, you can't have an improper fraction within a mixed number. So let's say we've already gone through the process of getting common denominators and all that. If I just keep this as is, 4 plus 2 is 6, keep the 8 on the bottom, 7 8 plus 3 8, 7 plus 3 is 10. Even if you reduce that and get 5 over 4, you cannot have an improper fraction within a mixed number. It just doesn't exist. You can't write your answer that way. Or one like this, when you're subtracting, I can do 9 minus 5 is 4. Keep the 5 on the bottom. 3/5 minus 4/5 would be negative 1/5. You can't have a negative fraction within a whole number that has a positive, or within a mixed number that has a positive whole number. That kind of answer does not exist. So to avoid that, one thing you can do is make them improper. I'm going to do the same problems, but I'm going to make them improper first. So on this one, I'm going to take 8 times 4 is 32. 32 plus 7 is 39. So I did that C method that we talked about on the first page of this video. So 39, keep the bottom on the bottom, plus 8 times 2 is 16. 16 plus 3 is 19. Keep the bottom on the bottom. As I'm adding, going to keep the bottom on the bottom. I know I say that a lot, but I'm hoping it's getting stuck in your minds. Across the top, I'm going to add 39 plus 19 and get 58. I can reduce that. They're both even, so let's divide them by 2. 58 divided by 2 is 29. 8 divided by 2 is 4. You can leave that as 29 over 4. If it's a word problem, I would convert it because, like I said in the last video, if you go into a store and somebody asks you what size of the thing is that you're wanting to buy and you say 29 over 4, you're going to look like a moron. So I would change it. Also, another reason is that if you're taking a standardized test, a state test, or a multiple choice test, it could be that your only answer choices are mixed numbers, not improper. Or it may say that you're required to write it as a mixed number. So the other way that you can do this, I know 4 goes into 29 7 times. That would be 28. So I would have 1 left over. So my final answer is 29 over 4, or 7 1/4. So that subtraction one, where we talked about how you can't have a negative fraction with a positive whole number, if I make them improper first, that won't be an issue. 5 times 9 is 45. 45 plus 3 is 48. Keep the bottom on the bottom. 5 times 5 is 25. Plus 4 is 29 over 5. Keep the bottom on the bottom. So now when I subtract, I don't have to worry about that second fraction having a bigger top number than the first one. If I do 48 minus 29, I just get a normal positive 19. Keep the bottom on the bottom. That's reduced. Or 5 goes into 19 3 times. That would be 15. So there would be 4 left over. 19 over 5, or 3 4/5. Let's do another example. And I've got a note over here. I usually get the common denominators after I make them improper. Some people make them improper after they get common denominators. It doesn't matter which one you do first, just as long as you get them both done. I just prefer to work with smaller numbers. And in my mind, when I'm multiplying for this C method to convert them, it's nicer before I change them to have bigger numbers for the matching ones. But whatever. I'm going to go ahead and I'm going to leave this as negative. 7 times 2 is 14. Plus 4 is 18 over 7. Minus 3 times 1 is 3. Plus 1 is 4 over 3. I need common denominators. 7 and 3 will both go into 21. So I'm going to rewrite these with a 21 on the bottom of each. To get from 7 to 21, I multiply by 3. So then I also need to do the 18 times 3, and I get 54. To get from 3 to 21, I multiply by 7. So then I also do 4 times 7, and I get 28. I'm going to leave the 21 on the bottom. And then I've got a negative 54 and a negative 28. If I owe one person $54 and I owe another person $28, altogether I owe $82. 82 and 21. Let's see. 3 goes into 21, but 3 will not go into 82. 7 goes into 21. 7 will not go into 82. So that's as reduced as that one goes. Or if I want to convert it, I know 21 times 4 is 84. So that means it'll only go in there 3 times. 21 times 3 is 63. And if I do 82 minus 63, I get 19 left on top. Just don't forget to rewrite that negative sign. Last one here. So there's my answer for that. But last one on this page. Right away, I see minus and minus. I see what in my class we call a face problem. I'm going to rewrite that minus and minus as a big old plus. I'm going to go ahead and convert them to improper. 10 times 1 is 10. Plus 3 is 13. Keep the bottom on the bottom. Plus 5 times 3 is 15. Plus 1 is 16. Keep the bottom on the bottom. I need a common denominator. You can use anything that they both go into. But if they both go into 10, I'm just going to take a shortcut and not change the first one. So I'm going to rewrite this as 13 over 10 plus, to get from 5 to 10, I multiply by 2. So then I take 16 times 2 and I get 32. I'm going to keep the 10 where it is. On the top, I'm going to take 13 plus 32 and I get 45. That can be reduced. If they end in 5 and 0, then they can both be divided by 5. So 45 divided by 5 is 9, and 10 divided by 5 is 2. You can leave it that way unless it's not allowed or unless it's multiple choice and you don't have an improper option. So you could convert that. 2 goes into 9 4 times. That would be 8. So there's 1 left over, 4.5. Whoops, too far. Now there is another option. If I hadn't converted them to improper fractions first, if I had added and I ran into one of those cases where I get an improper fraction within the mixed number. So I have a whole number and an improper fraction. Remember, that's not allowed. The other thing you could do is just fix your answer, correct your answer. So this 8 and 9/7, think of it this way. I have an 8 and I'm going to put a plus sign when I say and. 9/7 is really 1 and 2/7 because 7 goes into 9 one time with 2 left over. Then I can put those together and get 9 and 2/7. If you want to do it that way, that is totally fine. Just don't forget to check, because if you end up with one of these weirdo answers, you have to fix that weirdo answer or it can't be counted correct. Let's look at another one. I'm going to take the 3 and I put a plus sign when I say and. 16 over 5 I can change. 5 goes into 16 3 times with 1 left over. If I add those together, I get 6 and 1/5. I am totally okay with you doing the problem as is, as long as you fix your answer. Please don't ever hand in a paper that says 3 and 16 over 5. The other problem that we ran into is when you subtract, but you end up with a positive whole number and a negative fraction, because that can't be. Like on this first one here, you could do 6 minus 4 and get 2, but then 3/10 minus 7/10 is negative 4/10. So that won't work. There is another option called borrowing. Just like when you learn to subtract and you learn to borrow from your tens digit or whatever, same kind of idea. I can borrow a whole number on this 6 and 3/10. I can borrow a whole number and make this a 5. Since I'm dealing with tenths, that whole number is really 10 tenths. So I'm going to add 10 to the 3. I'm going to add my bottom number with my top number on my fraction and make that sum the new top number. So I'm going to rename this 5 and 13/10 minus 4 and 7/10. Let me talk you through that one more time so that you don't have to try to back up the video right there if you got lost. I borrowed a whole number. So I changed the 6 to a 5. A whole number would be 10 tenths. So I added 10 tenths to my 3/10 and I made it 13 tenths. So now I can do 5 minus 4 is 1. 13 tenths minus 7 tenths is 6 tenths. And then I would reduce that to 1 and 3/5. I'll show you one more of those, but honestly, if that seems like a bunch of mumbo jumbo, when I was a 7th grader, I hated this borrowing thing. It's just one of those things that did not click with me as fast as changing them to improper first. You got to do what makes the most sense to you. If you like the borrowing thing, or you think you might, here's another one. I'm going to borrow a whole number and make this 11. And you don't have to do this every time it's a subtraction. It's only if you're going to end up with a positive whole number and a negative fraction, because that kind of weirdo answer is not okay. So if I borrow a whole number, I'm dealing with fourths. That would be adding 4/4 to my fraction. Or add your bottom number with your top number. Make that 5/4. Then I can do 11 minus 9 is 2. 5/4 minus 3/4 is 2/4. And that would reduce to 2.5. Okay, so if you've watched any of my videos before, you know I always end on the same note. If there's anything else you need help with for 7th grade math, check out my YouTube channel. Please check out my classroom Facebook. If you're one of my students or family member of one of my students, you'll see all the homework and everything I've posted there, just updates about cool things we're doing in class. If you need to get in touch with me, there's my email, or please leave a comment here. I'll do whatever I can to help you. Hopefully you got something out of this video. Thank you so much for taking the time to watch.